It's a beautiful morning to finish Algebra 2, August 2016 exam. Yeah, we are going to do numbers 32 through 37. I apologize for that intro. It was something I had to do. Anyways, we are going to do the big boys. This is the 5th video for the Algebra 2 August 2016 exam. And again, it will focus on the last handful of problems, the last set, numbers 32 through 37. Let's get at them. Number 32 is a data or a stats problem. Look at given events A and B such that the probability of A is 0.6, the probability of B is 0.5, and the probability of A or B is 0.8, determine whether A and B are independent or dependent. There are two forms. There are two ways to check for independence, okay? First, you can say the probability of A given the probability of B equals the probability of A. If this is true, then those two events are independent. This is the first method. Okay? I only recommend doing that method if it is given to you, if A given B is in the problem. I don't see that anywhere in our problem here. Okay? So I'm not going to use option 1. The second method to check for independence is if the probability of A and the probability of B, the probability of A and B equals the probability of A times the probability of B. All right, I am definitely going to use this one. All right, but as I look into our problem, I see, all right, let's do this highlighter. We have the probability of A, that's good. We have the probability of B, that's good, but I don't have this right here. I can find the probability of A and B if I know the probability of A or B, okay? There's that one rule for or that involves and, okay? And we're going to use that. And this is really going to be kind of like a two-step problem, all right? So let's just go right into it. The probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. Okay, this is what I'm going to try and find out because then I will have that third and final piece to check for independence. All right, so let's put numbers where we know. A or B is 0.8. That's right here. Equals probability of A is 0.6 plus the probability of B is 0.5 minus, let's just, okay, I'll write this whole thing out. I hate writing. I wish I could just put A and B without the P, but on the test, you should really write it the way I have it. So point A equals 0.11 minus the probability of A or B. Okay, at this point, you should know that the probability of A and B, I'm sorry, that's and, the probability of A and B is 0.3. Because 0.11 minus 0.3 is 0.8. But let's do this algebraically. Minus 0.11. So we get negative 0.3 equals negative probability of A and B. And I'll just divide both by negative 1 because I don't want negative probability here. I want to get rid of that. I want that positive. So ultimately, when everything is said and done, the probability of A, oh, look what I did there, and B is 0.3. Now I have this. Look at that. 0.3. Does that equal the probability A, which is 0.6, times the probability of B, which is 0.5? Well, 0.3 equals, if I multiply those together, that is absolutely 0.3. So they are independent. And make sure you answer the question. So A and B are independent. Here is the answer. Okay? That is what they're asking you. Determine whether A and B are independent or dependent. All right? So make sure you answer the question, and we did. All right? I don't think this was that bad at all. The big thing, and we went over this in Unit 5, there were two things to remember. The given, all right, and this also came into play. Okay, I also talk about the 95 percenters. When it comes to probability and the probability of one event or another, the given and this thing I circled in green here for the or are two big things to know. All right, that was the final 2-point question. We are on to part 3, where they are getting 4 points each. Clearly state all necessary steps, utilize information provided. A correct answer with no work gets 1 credit. Again, out of 4, if you do something where you use the calculator to get the answer, at least write that down to get your 1 out of 4 points. Don't, leave it blank, get 0 out of 4. Now, if you're just being lazy and you don't write down your work and get 1 out of 4, shame on you. All right? Shame on you. Party tree. Find algebraically the zeros for p of x. And they give us this cubic. All right? If this was a quadratic, I can algebraically find the zeros by booty cheek, T-bone, the whole 9 yards, factoring and solving, so to speak. All right? But anytime I have more than 3 terms, if I have 4 terms, chances are I'm going to have to factor by grouping, especially algebraically. There's no other way that we teach you algebraically to solve for zeros with 4 terms other than factoring by grouping. So let's go ahead and do that. I take the first 2 terms here and group them. And I take the second 2 terms. That's why we call it grouping, in case you didn't know. And I'm going to factor these out. So what can I factor out of my green parenthesis? An x squared. That will leave me x plus 1 left. The whole point behind factoring by grouping is I want what's left in parentheses for both of these to be the same. So ideally, I want to take something out of the blue that's going to leave me x plus 1. And if I take a -4, if I factor a -4 out, that's exactly what happens. All right? That is really the first part, and then there's really only one more part to do. Is to kind of separate these things, meaning I take my x squared and my -4. Whatever is outside the parentheses, I group together outside, okay, in its own parenthesis. These get put into one parenthesis. I don't have to write it twice. I have to write it once. All right? Now, if I'm solving for 0, just make those equal to 0. Now, as I look at that left parenthesis that I have in black there, x squared minus 4, I should notice that that can also be factored. Again, that is a DOPS, a difference of perfect squares. That could be x plus 2 times x minus 2, right? That's this whole thing right here. And then I still have my x plus 1 equals 0. Now I can T-bone this. I get my answers. X equals -2, x equals +2, and x equals -1. Now, think about this for a second. We have a cubic. The degree, or the biggest exponent, my friends, is 3. That should tell me that I should have at most 3 answers. If I came up with 4 answers, I did something wrong. Okay? So 3 answers, the degree is 3. I like what I got. That's correct. Now, children. Oh, let me change the view here so we can see everything. View. Zoom. Let's go to 75%. That's too much. View. Zoom. A hundo. That'll work. All right. So I've got to graph this. All right. On the set of axes, graph this. You have a calculator. I would highly suggest that you put, okay, they're asking you to graph P of X. This is P of X right here. Okay, this whole cubic that we got. Put that in the calculator and get your table of points. This window we have, this graph that they've given us to draw on, is 10 by 10. Okay, so when I open this up and I go to y equals, I already have this in. I have x cubed plus x squared minus 4x minus 4. All right, my window is already 10 by 10. And this is what my graph should look like when I'm all done. All right, don't just try and draw what you see here. Actually go to your table. All right, and let's plot some points here, shall we? This is my table that I have right here. There it is. All right, and when everything's all said and done, I'm really just plotting these points. I'm going to -3, -10. I'm going to plot these points. -3 down to -10 is right here. All right. Now I'm going to plot -2, 0, which is right here. Now I'm going to plot -1, 0. Notice solution, because there's a 0. Solution, 0. Solution, 0. See our answers? Those are the 3 we came up with. So that's a great way to check those answers. All right. So let's keep plotting points. 0, -4. 1, 2, 3, 4, right here. Then I have 1, -6, which is slightly down more. And I have 2, 0, which comes back here. And then 3 is 20, so this is 10. It's going to go all the way up. It's going to be way up here somewhere, even higher. All right? So I'm going to draw this. Arrowheads, please. It's going to come up, slightly above, down, through, bang, something like that. Come all the way up, something like that. And please put P of X, label it. Okay? Now, you don't have to do this, but since I like doing stuff like this, bang, I put this here. And I do this here. I like to see you obviously can't do this on the test. So I'm going to kind of make it almost see-through. And you'll see as we put our graph, it lines up. Come on, there you go. Almost perfectly with what we have. Look at that. If I do that right here, and okay, there's the graph. There's our red one. Okay, that is perfect. Look at that. That is nice. We are good at what we do. All right. So I think that was a real easy 4-point question, as long as you remembered how to graph algebraically. Excuse me, factor by grouping algebraically. I mean, the graph, that's just a home run. Put that right in the calculator, man. Do it. Number 34. Oh, Lord, that is an exponential or trig. In this case, it is an exponential problem. One of the medical uses of iodine-131, which they creatively call I-131, a radioactive isotope for iodine, is to enhance X-ray images. The half-life of I-131 is approximately 8.02 days. A patient is injected with 20 milligrams of I-131. Determine to the nearest day the amount of time needed before the I-131 in the patient's body is approximately 7 milligrams. All right. Half-life. Anytime we do a half-life, well, growth and decay, I guess. The ending amount equals our beginning amount, I'll call that little a, 1 minus r, because it's half-life, to some time. All right? Now, let's start plugging in some numbers that we have here. The ending amount, they want to know when there's 7 milligrams left. Initially, this patient was given 20 milligrams. So that's our little a. 1 minus half-life is 50%, or 0.50. How much time? They want that to the nearest day. So I'm going to tell you something. Time, they want to be 1 day, okay, because this is in days. However, my half-life, okay, if you pay attention to what the problem tells us, isn't per 1 day, it's per 8.02 days. So this is the way I do it, okay? This is what I ultimately want. Right now, with what we have here, my time, this time, is 8.02 days. How do I know that? Because my half-life, my 0.5, means this t has to be 8.02 in increments of 8.0. But I want this to be 1. How do I make 8.02 into 1? If I divide this by 8.02, I can divide this by 8.02. All right? So now, that's technically 1t, all right, over 8.02. So let's just leave this 8, or t over 8.02. Now, that's 1 day, okay? Because this, if I factor that out, equals 1. So if I want to rewrite this, I say 7 equals 20 times, I'm just going to do this math, that's 0.5, and that's t over 8.02. That's what I'm going to solve. I have a variable in the exponent, so I'm going to have to use log or natural log to bring that down. So let's go ahead and do that right now, okay? Let's just solve for this. First thing I'm going to do, before I can bring the exponent down, I need to get my base and my exponent alone. So I'm going to divide both sides by 20. I want to get rid of that 20. Is that 0.35? Let's check this out. 7 divided by 20. 0.35. Ooh, that works out nice. 0.35 equals 0.5 t over 8.02. All right? 0.5. I've got to use log or natural log. I like to use ln because I just like to write one less letter. When I do that, I've got the natural log of 0.35 equals. Okay, this comes down now. t over 8.02 times the ln of 0.5. Now we're just going to rip. We're just going to peel or rip away values away from that t until I solve for t. All right? The first thing I'm going to do is I'm going to divide this side by the ln of 0.5. Divide by the ln of 0.5. Please, the ln's do not cancel. Okay? They are like square roots. I can't take the square root of 4 over the square root of 2 and say, oh, the square roots cancel. That's 2. It's not. The same thing with ln. It is an operation. Okay, you cannot just cancel it. So what I have next, and I'll move this over here, I have the ln of 0.35 over the ln of 0.5 equals t over 8.02. In order to get rid of that 8.02, I'm going to multiply. I'm going to multiply this side, okay, this whole thing, by 8.02. So my t is going to approximate, because I'm going to round it, should equal the ln of 0.35 over the ln of 0.5 times 8.02. Let's put that in the calculator, because there's no way you can do that without it. So the ln of 0.35 divided by the ln of 0.5, I'm going to hit enter, and then I'm going to multiply that times 8.02, 12.14687, etc. They want that to the nearest day. So t is approximately 12 days. Because this is going to round, that is going to stay at 12 because the number after it is less than 5. There you go. That was a little bit more detailed work. I mean, it was really just all algebra after we set it up. You need to understand this part right here, okay? Why I made the exponent t over 8.2. All right, that's the big thing. All right? Well, there's a 4-point question. There's going to be a little bit more of a hook in it. 35 straight up algebra. Solve the equation, the square root of 2x minus 7 plus x equals 5 algebraically and justify the solution set. This means you're really checking your work to make sure it works. You're going to get an answer, and they want you to justify it. Okay, you can have the work, but whenever it says justify the solution set, I like to just check it. All right. In order to get rid of a square root in any equation, I need to get it alone and then square both sides. I don't want the crayon. So I'm going to get this alone, which means I'm going to subtract x from both sides. Boom. So I've got the square root of 2x minus 7 equals 5 minus x. Now, in order to get rid of the square root, I square both sides. The square and square root just cancel. I got 2x minus 7 equals. This will give you 25 minus 10x plus x squared. This is not 25 minus x squared. You do not just square both of the terms. That's the same thing as saying 5 minus x times 5 minus x. I need a FOIL, okay? And when I do, that's what I get on the right side. All right? So this is obviously a quadratic. I need to get everything to one side, set it equal to 0, booty cheek, T-bone, and get our answers. All right, so I'm going to add 7 to both sides. I'm going to subtract 2x from both sides. And I'm going to write this in standard form, meaning my x squared is going to be written first. Then I've got my negative 10x and negative 2x, which gives me negative 12x. And I got 25 plus 7, which is 32. Oh, beautiful. Beautiful. 0 equals x. Yeah, let me factor that first. Two numbers that multiply to positive 32 that add to negative 12. Negative 4, negative 8. That works out perfect. Booty cheeks, and now I T-bone them. X equals 4 and x equals 8. Now, they want me to justify this solution set. That means I'm going to take x equals 4 and x equals 8, and I'm going to test it. I'm not going to test it here in red or here in black, I'm going to go to the original equation and test it, okay? So I have the square root of 2x minus 4. So it's a square root of 2 times x, which is 4 in this case, minus 7, did I say 4, plus x again, which in this case is 4, that should equal 5, okay? Square root of 8 minus 7 plus 4 equals 5. The square root of 1 plus 4 equals 5. 1 plus 4 equals 5. 5 equals 5. Cha-ching, check it. It works. Going to do the same thing with 8 to make sure it works. The square root of 2 times x, in this case it's 8, minus 7 plus x again, which is 8, should equal 5. In case it's a square root of 16 minus 7 plus 8 equals 5. I should know right now that's not going to work, but let's keep on going. Okay, let's just verify it. Square root of 9 plus 8 equals 5. And every time you get an answer that doesn't work with a square root, it tries to work but quite doesn't. 3 plus 8 equals 5. 11 does not equal 5. All right? Because if I took 8 and I subtracted 3, I'd get 5. Okay, but it really, the ones that don't work kind of look like they could work if you changed it slightly, but they don't. So what does that mean? That means this is my answer, and you should put a line right through that. That's fine. What I tell my students is I would write here that this is an extraneous solution. That means you got it algebraically, but it doesn't quite work. All right? Welcome to the land of 4-point questions. It's simple algebra, but it's a little bit more writing, okay? Some people might say that this is justification right here, but this doesn't justify that 8 doesn't work. This is your justification right here that 8 doesn't work, all right? I always go the extra step so that someone doesn't take points off my test. Number 36, another data problem. Data and stats, data, whatever. Ava designed an experiment to determine the effects of a new energy drink on a group of 20 volunteer students. 10 students were randomly selected to form group 1. Okay, group 1, right here, 10 students. While the remaining 10, okay, group 2. Okay, group 2, all right. Each student in group 1 drank one energy drink. Energy drink, all right? One energy drink, group 1. And each student in group 2 drank a cola drink. Cola. Now, 10 minutes later, their times were recorded for reading the same paragraph of a novel. The results of the experiment are shown below. All right, group 1 is the energy drink, group 2 is a cola drink, all right? Look at, these are all the times, it's beautiful, and the means or the average for each one of those groups is at the bottom. This is good. Now, there is no way that you guys should not be able to answer part A. The part B might be a little tricky. And I tell this to my students that you should at least get half credit here for part A. Part A says the following. All right? Ava thinks drinking energy drinks makes students read faster. Using the information from the experimental design or the results. So the way she designed this experiment or the results of this experiment, explain why her hypothesis may be incorrect. Do not give me an excuse why she might be right. Don't sit here and be like, well, the mean is smaller for the group 1, so she's right. They're saying, give me a reason she might be wrong. All right? Again, that word is italicized. That does not mean invisible. All right? So why could she be wrong? There could be a handful of answers that would be right here. That could be correct. What I would say is the following. This is what makes this easier for me. She says the energy drink makes people read faster. Right off the bat, the 2 fastest times are actually in group 2. Yeah, the average might be not as fast. The faster average might be group 1, but the 2 fastest times are in group 2. And that's what jumps out to me. So I would write here, explain why hypothesis might be incorrect. I would literally say that. The 2 fastest reading times are actually in group 2, and I'll put in parentheses the cola group. That's it. Now, one of my students raised their hands and said, well, how about the way she organized it? Maybe she put more of the faster readers in group 1. That's why their average is. I mean, even without drinking the energy drink or the cola drink, the faster readers might have been in group 1 in general. That's why their average is faster. That's another great answer you could do, because not only are they saying from the results, which I used, but from the design of the group. Okay, maybe, coincidentally, more of the faster readers were in group 1, so the average overall is faster. That's a design issue. You could answer that way as well and get credit for part A. All right, this should not be the difficult part. This, my friends, is where you might have struggled. Now, using the given results, Ava randomly mixes the 20 reading times, splits them into 2 groups of 10, and simulates what she just did 232 times. Here's all the results. Now, Ava has decided that the difference in mean reading times is not an unusual occurrence. If it is not unusual, that means it. Yep, I should put an S between there. If it's not unusual, it is usual. That means it's common. Yeah, I don't know what's up with my spelling today. That means it is in the 95% moneymaker. Okay? If it is a usual or common occurrence, that means it's not unusual. That means it's in our 95% moneymaker. Okay? Yep, bang, bang. All right, now it says support her decision. So tell me why she's right this time. You like what they do there? Part A, they want you to explain why she's wrong. In part B, they want you to explain why she's right. Or she could be right. And explain your reasoning. All right, first of all, the differences in group 1 minus group 2. Remember, subtraction order matters. So this is the difference in the means. Let's figure out what the means were in her experiment, because she says this is not unusual. Group 1 is 17.7. Group 2 is 19.1. So I go right here, and this is 17.7 minus 19.1. Let's get some space here. Badoosh. So if I actually take 17.7 and subtract 19.1, oh, that's a negative number, my friends. Okay, to get to 19, it should be 1.3 plus 4, 2.4? 2.4, negative 2.4? Let's do this. Whenever in doubt, use a calculator. On. I'm going to take 17.7 and subtract 19.1. Make it negative 1.4. Did I say 2.4? I meant 1.4. That's just what I meant. So, negative 1.4. This was her actual group. This is what she's saying is common. It's usual. It is not unusual right there. So let's look at our chart here. Where would negative 1.4 fall? Each one of these spaces here, okay, in between the tick marks, represents a tenth. All right? So if I go down here and I go down the line, negative 1.4 is right, and I will highlight this. This line right here, right there, that is negative 1.4, okay? So she says that is common. That is inside our 95%. So this is what I'm going to do, and I think this is the best way to do it. You see how they've got numbers, like we got occurrences, like quantities of the event happening? Right here comes to this line, which is a quantity of 1. Right here comes to this line, which is a quantity of 2. So I'm going to add up all of these, okay? This went to 1, 1. This goes all the way up to, oh man, 5. Okay, this goes up to 2, 2, 3, 2, 1, 2, and 3. Everything that's negative 1.4 or less, okay, is that quantity. So what I'm going to do is I'm going to add all of these up. All right, so I'm going to take 1, 2, that gives me 3, plus 1 gives me 4, plus 1 is 5, and so forth. 10, 12, 14, 17, 18, 20, 22, 25. There are 25 outcomes, all right, that are negative 1.4 or less. So what I'm going to do is this. There are 25, yep, that's highlighter stuff. So let's do this. There are 25 outcomes out of how many did she run? 232. So 25 out of 232. That is right where her number falls. Okay, 25, I guess, outcomes into the 232. Does that make sense? These 25, you need to add up 25 outcomes just to get to her experiment number of negative 1.5. So what percent is that? All right, well, let's do this. Let's take 25 and divide it by 232. And that is roughly 10.8%, let's call that. All right, I'm going to take that 10, make it into a percent. All right, so I got to slide the decimal over twice. So this decimal is going to move over 1, 2 spots. That is approximately, let's call it 0.108. So that's 10.8%. Is 10.8% within our 95%? It is. Okay, and let me explain something quickly here. You probably don't have to do this on the test, but it's a further explanation for you. If this is our bell curve, okay, and my 95% moneymaker, which means all usual outcomes, are in this range right here. That means there are 5% out of my 100%, 95 are common. Okay, that means 5% are not common. Okay, they're on the outside. Half of those would be to the right, and half of those would be to the left. That means 2.5% would be on the high end, and 2.5% would be on the low end. These 2.5%, if I add them, give me the 5%. Then when I add to 95 is the 100% of all my possibilities. All right? 10.8% is right around here. Okay? Because this is 2.5%. We start at 0%. Here's 100%. 10.8% is within the 95% common occurrence. Okay? Do you have to write this on your test? No, I don't think you have to. But you do have to state. Explain means use words. Okay? I say, yes, Ava is correct. And how come? Because 10.8% is within the 95% common occurrence or outcomes, whatever, however you want to write that, occurrences, common occurrences. Now, maybe you want to say, yes, Ava's correct. It is not unusual. Maybe you want to use the words that she said, that's in the problem, that it is not unusual, okay? But this is what you need to write. This thing is always in the way. This is what you need to write, absolutely. Okay, that's going to give you your answer, all right? That would have been tougher to get. Answer the question in this part. Okay, 6 points. Clearly indicate yada, yada, yada. Utilize information given, yada, yada, yada. A correct numerical answer with no work receives 1 credit. Out of 6, you get 1 unless you're not lazy. Or if you're guessing, who knows. But let's go ahead and take a look at this part 4, which is the final question, number 37. Seth's parents gave him $5,000 to invest for his 16th birthday. He is considering 2 investment options. Option A will pay him 4.5% interest compounded annually. Option B, okay, that's option A, that was. Option B will pay him 4.6% compounded quarterly. Write a function for option A and option B that calculates the value of each account after n years. Now, they say n, which means instead of using t, your variable t, you got to use n. All right? So option A, which I've underlined in red, I will say A of n equals. All right, this is growth and decay. It's your principal times 1 plus your rate times time, which we are going to, or raised to time, which we are going to call n. All right, so A of n is going to equal, he has $5,000 to put in, right? 1 plus 0.045. You got to slide that decimal over twice to the n. If you want, you can say a to the n equals 5,000, and you can combine those and say 1.045. That's fine to the n, but you don't have to. I always say, why do extra work if you don't have to? That would have been correct. This is what you need. Done. Okay? Anytime I'm compounding anything annually, that's it. There's no compound amount. Annually is just once, so it's nice and clean just like this. B not only has a different percent, but it's compounded quarterly. That means they're going to compound the interest 4 times a year, every quarter. That means we have a K variable. All right? And when we have a K variable, it is exactly the same. It's your principal. It's 1 plus your rate. Notice I rose that a little higher. And you have your time and n. But K makes its ugly face show up twice. You divide your rate by K, and you multiply your time by whatever K is. All right, whatever. So if it was monthly, your K would be 12 because there are 12 months in a year. It's quarterly, your K is 4 because there are 4 quarters in a year. Okay, if it's semi-annually, there are 2 semis. Okay, semi means half. Okay, that would be 2 a year and your K would be 2. So let's plug in the numbers that we have. B of n equals 5,000 is still the initial value. Still what I'm putting in first. 1 plus 0.046. That is off. That is different by a tenth over K, which is 4, times n, or excuse me, raised to n times K. K is 4, so I'll say 4 times n. There you go. All you had to do was take numbers literally out of the problem. Why is this a 6-point problem? These two equations are different based on whether it's compounded. If it's compounded more than once, you have to use the K. Okay, if it's not, you can do it this way, which makes it easier. All right? So let's take a look at the second part. They're asking us, Seth plans to use the money after he graduates from college in 6 years. Determine how much more money option B will earn than option A. So I need to find out, all right, 6 years. This is my n value, 6 years. So I need to find out what A of 6 equals. Okay, and I need to find out what B of 6 equals. Okay, but that's just not my answer. They want to know how much more money B will earn. You should have more money in B when you're done. If you don't, you've done something wrong. When you have those two values, subtract them because we want to know that difference, okay, to the nearest cent. All right, so I'm going to take 5,000 and multiply it 1 plus 0.045 raised to the 6th. That's going to give me A. All right, B, I'm going to take my 5,000, 1 plus 0.046 over 4 to the 4 times my n, which is 6. I'm going to get 2 values there, and I'm going to do them both in the calculator. Why would I try and do them any other way? Sillies. Turn on. There you go. 5,000 times, that should be another 0, times 1 plus 0.045, parentheses, raised to the 6. Just going to put this here, just so that we have it. There it is. And now I'm going to do here, I'm going to do the same thing. 5,000. This is for part B. Raised to the 1 plus, got to use my fraction, 0.046 over 4. And I'm going to raise that. Well, I know 4 times 6 is 24. So I'm going to make my exponent 24. That's good, you can. I just have the calculator do everything for me. I type it exactly as it is on my paper. You will get the same answer. All right? So, to the nearest cent, A is 6511.30. Okay? Option B is 6578.87. That will round up because the number after it is 5 or bigger. So what's the difference? I take my 6578.87 and I subtract my 6511.30 and I get an answer. Again, I'm tired. It's been 2 hours I've been doing this. I'm going to take my bigger number, hit enter, and I'm going to subtract, go up here, this number here and hit enter. It's going to have the calculator do it for me. You should get, at the end of 6 years, $67.57 more. There you go. This is the answer. These are not the answers. They want to know how much more money option B will give you. That's this right here. Okay? So far, this 6-point question is not difficult at all. Okay? This last part might give you a little, squeegeesy. Anyways, algebraically determined to the nearest tenth of a year. I'm solving for n because n is my time. How long will it take for option B to double Seth's investment? First of all, he's investing $5,000. If I double that, that's $10,000. Okay? Let's use option B, which is this right here. Okay, now keep in mind, we're solving for n, so we don't know what n is. So really I'm using this. Okay, I'm using this equation right here. All right? So I don't want to put my 4 in because my year isn't 4. We are determining the year. Okay? So he's starting with 5,000. 1 plus 0.046 over n. Okay? Nearest 10th of the year here. So algebraically determined. Times 4 to the n? Yes? Good. Option B? Good. We're good. We're not good because that n should be a 4 here. I'm sorry. This stays the same. That's my k. K is the same. I'm just solving for n, which stays the same right here. All right? So let's do this. All right? First thing I'm going to do is I'm going to divide by 5,000. Divide by 5,000. So now I've got, 2 equals. All right, let's put this in the calculator and see if it gives us a nice clean decimal. 0.046 divided by 4. Oh, 0.0115. Okay, so if I take, this is 0.0115 and replace this. 1 plus that, it's 1.0115. Raise to the 4n. I have an exponent that is a variable. I need to use ln to bring it down. So now I've got the ln of 2 equals 4n times the ln of 1.0115. I am multiplying n times 2 things, by 4 and natural log here. So I'm going to get rid of those by dividing by 4 and natural log of 1.0115. Cancels with this, so n equals. What I do to one side, I have to do to the other. I'm literally putting this in the calculator and seeing what I get. So I take, and let's take a look at what we got. The ln of 2. Okay, enter. Let's just make a fraction. Let's do it nice and clean. It's the ln of 2 over 4 times the ln of 1.0115. So how long would it take for this dude's money to double? 15.15. They want that to the nearest what? 10th of a year. That's 1 decimal place. This will round up to a 2 because the number after it is 5 or bigger. Label it, please. That's years. Thank you for joining me on this journey through the August 2016 Algebra 2 exam. And maybe, who knows, maybe we'll do the January 2017 exam next. Thank you. Keep studying. You got this.